Breaking news from the frontier of our solar system. A faint point of light has appeared where none was expected. A stranger moving swiftly through the darkness between the interstellar visitor, 3i Atlas, and the orbit of Earth. Astronomers across several observatories confirm that this is not a background star. Not a reflection, but a new traveller entering our view. Its name is C2020 V1 Borisov, a designation that immediately draws attention. The discoverer, Gennady Borisov of Crimea, is already known to the astronomical community. Years earlier, she had identified 2i Borisov, the second confirmed interstellar object ever observed. Now, another of her discoveries has appeared, this time right between us and the wandering comet Atlas. The coincidence is striking, almost poetic. Two distant travellers, their paths crossing briefly under the light of the same sun. At first glance, V1 Borisov does not behave like Atlas. When telescopes first turned toward its position, observers expected a glowing tail, the signature of sublimating ice streaming into space. Instead, most images showed only a dense, smoky haze with no clear extension. A few reports hinted at a faint, uncertain tail, but the majority revealed simply a round, ghost-like cloud. This lack of structure is unusual. Ordinary comets, even faint ones, display some sense of direction, the dust drawn outward by solar radiation, but V1 Borisov seems to defy that pattern, keeping its material close and shapeless, as if the sunlight had touched it but failed to awaken it fully. Still, it is bright enough to draw attention. Instruments measure its apparent magnitude, increasing slightly as it moves closer to the sun, but not explosively. Not with the dramatic outgassing seen in Atlas. It glows with a subdued persistence, a restrained kind of activity. Spectroscopic measurements suggest only weak emissions, traces of carbon compounds, and perhaps ionized dust, but no strong signs of water vapor or classic cometary volatiles. For scientists, that quietness may be the most intriguing feature of all. Its orbit places it closer to the sun than 3i Atlas, and that proximity matters. The path of Borisov threads between the inner planets, crossing regions now alive with solar storms. The sun, at the height of its magnetic cycle, has unleashed a series of flares and coronal mass ejections in recent weeks, waves of charged particles racing through space. These storms strike every object in their path, compressing magnetic fields, igniting plasma tails, and sometimes triggering jets from frozen nuclei. To find a newcomer moving through that turbulent environment is both an opportunity and a challenge. What effect will the solar wind have on this quiet body? Will it remain dormant, or will heat and radiation coax it into sudden activity? As the news spreads, observatories across the globe turn their instruments toward the coordinates. Early morning skies fill with faint exposures, long tracking sequences, and quick analyses shared through online networks. The first composite images confirm what had been suspected: a small, compact object surrounded by a thick veil, with only the faintest hint of extension toward the anti-solar direction. Its behaviour defies easy classification. It is neither fully active nor fully inert, a grey area between asteroid and comet, between silence and awakening. Meanwhile, the companion visitor 3i Atlas continues its own passage beyond perihelion. Having swung around the sun in late October, it now bears the marks of its encounter, the scars of solar radiation, the remnants of magnetic storms. Images taken from solar observatories show its faint tail frayed and uneven, the once stable coma disturbed by repeated bursts of energy from the sun. It glows more faintly now, yet still its activity persists, like a distant ember slowly cooling as it drifts outward. The contrast between the two objects could not be sharper. Atlas, active and luminous, shows every sign of a comet heated from within, its jets dancing in the solar wind. Borisov, close to the sun yet quieter, remains a mystery, a cold traveller wrapped in dust. Why does one flare while the other remains still? The answer may lie in their composition, their histories, or perhaps their origins among the stars. For now, the focus turns to continued observation. Every night brings new data, new images, new light curves. Astronomers seek to determine whether V1 Borisov will awaken as it approaches perihelion, or whether it will remain a dark interloper, absorbing light but giving little back. As the days pass, The sun rises earlier over observatories around the world, washing the faint object from view. But for a moment brief, silent, and luminous, the solar system has two visitors from the deep, passing each other within reach of our telescopes, sharing the same star before returning to the long dark between worlds. Even now, with weeks of observation behind us, C-2025 V1 Borisov remains a mystery. Telescopes continue to trace its faint movement against the backdrop of the stars, yet it still shows no clear tail, not a single bright ribbon of dust trailing behind, no line of light to mark its path through space, only the diffuse glow of a compact, smoky envelope. To astronomers, this silence is perplexing. The sun is close, the radiation intense, the conditions ideal for sublimation, and yet the object refuses to display the behavior of a typical comet. Strange. Yes, but in the world of observation, strange is often where discovery begins. While ground-based telescopes wrestle with faint and shifting light, new information arrives from farther away from Mars. In early October, before 3i Atlas reached its perihelion, the Tianwen probe, an orbiter operated by the Chinese Space Agency, captured a sequence of distant images. For weeks, those data remained unprocessed, hidden behind the usual layers of calibration and internal review. Now, at last, the images have been released. They are low-resolution fragments of light and shadow taken through the thin, reddish haze of the Martian atmosphere, yet their significance lies not in their clarity, but in their perspective. From orbit around another planet, Tianwen recorded the interstellar visitor Atlas as it crossed the inner solar system. The probe's camera, originally designed for monitoring dust storms and auroras on Mars, was pointed outward for a series of long exposures, collecting photons that had travelled millions of kilometres through interplanetary space. The result is a set of ghostly frames, Atlas appearing as a pale smudge beside the bright limb of the sun, its coma faintly visible, its structure almost lost to glare. Still, these are the first confirmed off-Earth observations of the object. From that vantage point, far from Earth's atmosphere, the sunlight scatters differently. Even coarse data can help refine estimates of brightness and dust density. Analysts in Beijing report subtle fluctuations in luminosity across the sequence, suggesting that the interstellar comet's activity was already fluctuating weeks before its outburst became visible from Earth. In other words, the transformation we witnessed in November may have begun earlier, unseen, while the object was still closer to Mars than to us. With China's data now public, attention turns to the remaining missions capable of contributing. NASA's heliophysics observatories, such as the Solar and Heliospheric Observatory and the Parker Solar Probe, may have caught glancing observations during Atlas's perihelion transit. The UAE's Hope probe, still orbiting Mars, might also have collected background data that include the faint trail of the interstellar object. If released, those images would complete a mosaic of viewpoints: Earth, Mars, and the interplanetary space between them all watching the same cosmic visitor. But for now, we have what we have: a new alien object, faint and reticent, and a new set of images of another interstellar traveller still glowing near the sun. Together, they tell a story of convergence. In the vastness of the solar system, two wanderers have entered at nearly the same time, moving along different trajectories but sharing the same stage of light. Their paths, though independent, invite comparison. Atlas active, radiant, shedding gas and dust as it races outward toward Jupiter. Borisov silent, closer to the sun, yet wrapped in mystery. If its orbit remains stable, V1 Borisov will reach perihelion in mid-November. Calculations predict that this will be its moment of maximum illumination, when the balance between solar heating and distance produces the strongest visible effect. Whether that effect will be dramatic or subdued remains unknown. If sublimation begins suddenly, we may witness a brightening a long-awaited tail finally forming under solar pressure. But if it remains quiescent, we will be left with something rarer still, a comet that refuses to behave like one. Meanwhile, 3i Atlas continues its outward journey, though still close to the sun's glare. It is drifting steadily toward the orbit of Jupiter. Its tail, once brilliant and intricate, now stretches thin, yet even from this distance, new solar flares continue to strike it, bursts of charged particles that spark faint glows in the surrounding gas. The object bears the scars of that encounter: irregular jets, fragmented filaments, subtle shifts in brightness. Each change tells of energy transferred across millions of kilometers, of ice turning to vapor under relentless light. Two objects, two stories both unfolding under the same star. From Earth and Mars, from China's Tanwen probe to telescopes scattered across continents, the data converge into one shared picture of motion and change. It is a reminder that even within our familiar solar system, there remain visitors whose behavior defies expectation. In the next chapter, we follow those visitors as they approach the sun's domain, one brightening, one silent, and uncover what their light reveals about the restless boundary between stars. Imagine standing before a living chart of space, a three-dimensional solar system map that breathes and turns with time. On its dark canvas, the sky visualization brings three enigmatic travelers into motion: 3i Atlas, C2025 V1 Borisov, and C2025 K1 Atlas. They do not trace the familiar ellipses of homegrown comets. Their paths tilt and cross, lean and twist, as if drawn by a hand that learned its geometry around another star. From Earth's vantage, something even stranger unfolds. The three bodies seem to drift toward one another across the same patch of night, closing an apparent triangle that tightens with each passing dawn. It is an illusion born of depth, like birds crossing the moon from different distances, and yet, as the map slowly rotates, you can feel why astronomers pause. Their orbits are unusual, and their angles of approach conspire to bring them into our line of sight at nearly the same time. Among the trio, K1 Atlas steals the eye first. It does not wear the cold blue of a classic ion tail, nor the chalky white of familiar dust. Instead, it spills a soft, gilded light, a golden plume that seems warmed from within. That colour is not a trick of the instrument. It is the signature of sunlight scattered by fine grains of dust, brightened by the angle at which we view it. When dust dominates and the sun stands at just the right slant, comet light can turn honey-coloured, as though a lantern were carried through fog. On the Sky-Eye map, K1 Atlas glides through Leo, a lion traced in ember tones. Close by on the display, Borisov holds to Virgo, a quiet smudge wrapped tight, reluctant to unfurl a tail. And there, just a narrow field away, 3i Atlas continues its own outward course, the interstellar visitor that woke after perihelion, its jets teased and ruffled by the solar wind. In the living model, the three bodies seem almost to nod to one another as they pass. Separate stories share in a page. Spin the map back to the view from Earth and the arrangement sharpens. On the 6th of November, if you step outside before dawn and let your eyes adjust, the sky projection shows the trio drawing very near on the dome of the sky, not in space, but in appearance. Lines of sight compress distance. Depth collapses into a single plane. 2 nights later, on the 8th of November, the alignment is closer still, a near-perfect thread of light as though someone had set 3 beads upon an invisible wire. The physics beneath that elegance is sober and precise. Each traveller moves on its own path, cut by gravity and nudged by sunlight. Their inclinations differ, each orbital plane a tilted sheet and then nodes. The points where those sheets cross the ecliptic fall at different longitudes. What we witness as a rendezvous is really parallax. The geometry of viewpoint, Earth sweeps along its orbit. Our gaze changes, angles close. The Sky-Eye tool renders this beautifully. Pull back, and the orbits separate like braided streams seen from above. Push in, and they crowd together against a backdrop of constellations. A reminder that the sky is a projection, not a map pinned flat. K1 Atlas's golden tail invites a closer look. Dust tails curve gently because grains, once released, keep a memory of the comet's motion even as radiation pressure urges them outward. When the sun sits at a low phase angle and the dust is fine, forward scattered light can bloom warm and bright. The result is that lantern-through fog glow, a colour that tells us as much about particle size as it does about beauty. 3i Atlas, by contrast, often shows narrow, filamentary jets that hint at gas ions shaped by the solar wind. Straighter, sharper, cooler in tone, and Borisov, still withholding a definite tail, suggests either larger grains that cling close or ices locked beneath a darker crust. The map is not only spectacle, it is a measuring stick for time. Watch the frames advance and the story resolves into sequence. Before the 6th, the triangle is wide. On the 6th, it narrows. By the 8th, it nearly stitches into a line. Afterward, the illusion loosens as Earth's motion carries our sightline past the knot. Nothing touched, nothing met. Yet the choreography tells us how space and viewpoint converse, how a planet in motion can make distant objects seem to approach. Salute and part. There is a quiet lesson in that sweep. We often imagine the sky as a fixed dome, a page on which events are written. The sky visualization reminds us that it is layered thick with depth, braided with motion, alive with changing angles. 3 travelers move independently, but for a handful of mornings they appear to gather under Leo and Virgo, as if drawn together by design. It is only geometry, and it is also a kind of grace. Hold the map in your mind as you step outside. The lion to the east, the maiden nearby, a pale thread of gold where K1 Atlas breathes, a quieter glow where Borisov keeps its counsel, and the interstellar Atlas, still writing its faint script in sunlight. What seems like meeting is perspective. What looks like order is motion seen from a single shore. And yet, in that fleeting alignment, the universe feels briefly legible, a sentence in a language we are learning to read. There are moments in the sky when motion slows and geometry seems to breathe. 3 wandering lights, Earth, Borisov, and 3i Atlas appear to draw themselves into a single, trembling line. For astronomers, it is a quiet puzzle. Is this mere coincidence, or the faint expression of some deeper rhythm, a hidden law of harmony that nature occasionally reveals? Back in early November, Borisov was still a newcomer, first recorded around the 3rd of the month. It rose into the sky from below the ecliptic plane, climbing like a small spark from the deep southern shadow toward the sun. Its track, steep and open, matched the shape typical of an extrasolar comet, a path not looping homeward, but cutting once through the solar system before vanishing again into interstellar space. At the time of discovery, it carried only a temporary label, a string of numbers and letters, GB00000810. That name, unpoetic but precise, marked its place in digital catalogues long before the formal title C2025 V1 Borisov reached the public bulletins. For a while, the early identifier was the more reliable search key, a reminder that discovery begins in data long before it blooms into story. As the orbital calculation settled, the numbers pointed toward a date of mid-November for perihelion, the moment when Borisov would brush closest to the sun. According to projections, that would occur on the 16th of November, a turning point both in distance and in energy. When the 3-dimensional model of the solar system is advanced to that day, a pattern emerges. The comet sweeps very near the sun but remains slightly above the ecliptic plane, its path slanting like a fine thread of glass. From Earth's perspective, the alignment is striking. Our planet, the sun, and Borisov nearly fall upon the same axis, the object poised just a little higher, glowing faintly in the glare. At almost the same moment, 3i Atlas occupies a matching geometry farther out. Its own path curves outward from the sun, crossing the same projection line that joins Borisov and Earth in the Skive model. When the view is rotated and scaled, the 3 bodies seem to fuse into a single, luminous rod, a cosmic axis of light stretching across tens of millions of kilometers. It is not a true meeting in space, yet the alignment is so precise that on the map it feels intentional, as though gravity and chance had conspired to sketch a straight stroke through the solar air. Astronomers watch such alignments with both fascination and caution. They know the physics, orbital planes, longitudes of perihelion, inclinations. The pattern is a projection, the result of geometry and timing, and yet, standing before the model, it is difficult not to sense something deeper, a resonance of motion that repeats across scales, from the dance of electrons to the turning of worlds. The term syzygy describes this arrangement, the near-perfect straight line of celestial bodies. It is an ancient word, used for eclipses and tides, for the moments when alignment amplifies light or gravity, when the ordinary pull of things becomes briefly magnified. In this case, no eclipse will follow, no visible event will mark the moment, but for those tracking the trajectories, the configuration itself holds meaning. It offers a rare chance to measure how sunlight scatters along a shared axis, how reflected brightness changes with viewing angle, and how the orbital mechanics of one visitor may subtly influence the apparent motion of another. The alignment also serves as a natural calibration for instruments, a straight line drawn by the cosmos against which sensors and calculations can be tested. On Earth, the scene unfolds in silence. In early morning observatories, astronomers tilt their telescopes toward the horizon of dawn, knowing that somewhere along that invisible line, two visitors from beyond our system are passing one another under the sun's blaze. They will never meet, never exchange material or light beyond what the solar wind dictates. Yet their orbits cross our sight as if choreographed, for the brief span of a few days. The alignment of Earth, Borisov, and Atlas becomes a living diagram, proof that perspective can weave poetry from mechanics. By late November, the pattern will dissolve. Each body will continue along its separate curve. But in that narrow window, the solar system itself seems to draw a straight line through its heart, a gesture of symmetry amid ceaseless motion, a whisper of order in the vast and beautiful drift. Some regard the alignments before us as a neat artifact of geometry, a coincidence produced by orbits and timing. Others feel the tug of a different idea, that there may be a pattern here that hints at a larger coherence, a quiet signal woven into the sky and only now coming into view. Between those positions lies the work of observation. We pose the question coincidence or sign and then watch, measure, and let the data decide. We enter this question during a restless chapter of the sun's life. The star is rising toward a peak in its cycle, and on the far side of Earth, vast sunspots have spread like archipelagos across the photosphere. Since the 21st of October, a chain of powerful storms has lifted from those active regions and swept into the inner system. Shock fronts expanding, magnetic fields draped and redrawn, radio noise rattling instruments from one dawn to the next. Models tracing those eruptions through space placed their paths in the same broad corridor that 3i Atlas was crossing after perihelion. To many observers, the timing feels pointed, as though plasma, motion, and chance had, for a handful of days, agreed upon the same longitude in space. A second traveller enters the frame, a newcomer informally called a 6 lemon. Its path threads the same quadrant, and when the three-dimensional model is set to the season of storms, a geometry appears with the clarity of a drafted line. Earth, the Sun, and Lemon lie nearly collinear at the very hours when the flare-bearing sunspots rotate into view, as if a bright ruler had been laid across the heliosphere. Rewind the clock to the 5th of November and the line holds. Advance it toward Lemon's perihelion, and the alignment tightens again. The temptation is obvious, to imagine that bursts of radiation will ride this axis, that what we call a coincidence might be the envelope of a longer, slower rhythm. The physics, stripped of romance, is already rich enough. Solar eruptions are steered by the sun's magnetic architecture. Their particles stream outward along fields wound into spirals by rotation and carried by the solar wind. Alignment does not cause a flare, but it can place an object along the most efficient routes for charged particles and light to travel. In such cases, the alignment functions less as a message than as a key, an orientation that lets us watch pre-existing flows with unusual clarity. When small bodies pass through those flows, their comet can brighten, their tails can sharpen, their spectra can show brief surges in emission. When they do not, the silence is itself a constraint on our models. Skepticism, carefully kept, is part of the craft. Alignments are common in a ski layered with depth and motion. The mind is tuned to patterns and will invent them when data are thin. The way through is to turn curiosity into test. Compare the precise onset times of flares to the heliolongitude of Lemon. Look for correlations between the rotation of active regions and particle events registered by spacecraft. Examine whether faint, synchronized brightening occurs in the comet of bodies sharing the same longitude. Search radio records for bursts that indicate magnetic connectivity along the line of sight. If such correlations persist beyond chance, the hypothesis earns weight. If they vanish with additional data, we accept the verdict and move on. Meanwhile, 3i Atlas continues to serve as a sensitive gauge of space weather. Since late October, its jets and filaments have responded to each gust of solar wind with subtle changes in shape and brightness. Should Lemon's passage coincide with renewed eruptions aimed along the same meridian, we will have, for a brief span, two probes of the same river of particles. Atlas a little farther out, Lemon nearer the sun. both sampling the turbulence, both offering hints about dust size, gas production, and the strength of magnetic draping. Even a null result will matter. It will tell us that composition and geometry, not alignment alone, govern response, that some nuclei remain quiet under conditions that rouse others, that the grammar of these interactions is more intricate than a single axis implies. So is there a cosmic signal here? If signal means intention, the evidence does not compel us. If signal means coherence or rhyme among solar magnetism, orbital geometry, and the angle of our looking, then the answer may be yes, but in the modest, durable sense that nature often offers, a pattern that helps us see more cleanly, measure more carefully, and understand a little more of how energy moves through space. For a few days in early November, the three-dimensional map drew a straight thread from Earth through the Sun to Lemon. Storms rose along similar lines. Atlas glowed beyond as it wrote its own response to the same star. Whether that arrangement proves to be coincidence or the outline of a deeper rhythm, it gives us a path to follow, observe longer, compare precisely, and let meaning accumulate at the slow, trustworthy pace of the sky. Solar physicists look ahead and see a restless star. They expect the elevated pace of flares and coronal mass ejections to persist for days, perhaps longer, not because an alignment causes eruptions, but because geometry can sharpen their effects. A resonance advantage that lets us watch the system's energy move with unusual clarity. In seasons like this, when active regions wheel across the sun's face and magnetic loops tighten like drawn bows, the inner system feels busier, brighter, more conducive to interpretation. Against that weather, the appearance of unusual visitors is easier to notice, easier to compare, and harder to dismiss as background noise. C2025 V1 Borisov is the emblem of that attention. By itself, it may be nothing more than a modest comet on a steep path, a body that would have come and gone without fanfare in a calmer year. Yet its discovery between 3i Atlas and Earth, and the timing with respect to heightened solar storms, has invited a familiar question: coincidence, or a thread in a larger tapestry we do not yet know how to read. The prudent answer begins with statistics. Alignments occur, surveys are more sensitive than ever. When the sun is noisy, we simply look harder and longer. But prudence does not forbid curiosity. It asks only that we turn it into method. Some analysts press the point further. Perhaps we should be slower to label every fast visitor a comet in the traditional sense. The word carries assumptions about composition, structure, and behaviour that were shaped by objects born in our own planetary nursery. Interstellar travellers may wear the same rough costume of ice and dust and still differ in the grain of the fabric. They are set under other suns, porosities carved by other cosmic ray histories, volatiles mixed in ratios our models do not expect. When one of these bodies refuses to grow a decisive tail, or grows one of unusual colour, or brightens in ways out of step with distance alone, the discrepancy is not an embarrassment. It is a measurement. It tells us where the map is thin. None of this implies intention, nor does it summon extraterrestrial craft from shadows. A rise in solar activity is the ordinary pulse of a magnetic dynamo. A string of newcomers is the ordinary consequence of better surveys searching more of the sky. If there is a signal here, it is not a message but a coherence, a rhyme among solar weather, orbital geometry, and human perception. In that sense, some liken the present season to a simulation that turned real, a rehearsal of overlapping phenomena that were once only scenarios on whiteboards. A flare surges from an active region. A small body crosses the same heliolongitude. Instruments on and around Earth record both and force us to reconcile their timings, their energies, their barely coupled effects. We are asked to hold more than one mechanism in mind at once and to let them interfere, as waves do, until a pattern emerges. Meanwhile, the storms keep arriving. Day by day, new eruptions lift from the sun's surface. The shock fronts steepen, and the interplanetary magnetic field drapes and snaps like a taut sail in shifting wind. Each event is an opportunity to test the posture of the sky. Do comets brighten when a storm sweeps over them? And if they do, by how much and how long? Do iron tails sharpen or twist under changing field direction? Do dust-dominated plumes warm in colour when forward scattering increases at small phase angles? And can we read particle sizes from that warmth with more confidence than before? These are not rhetorical questions, but practical ones. the kind that turn wonder into calibration tables. For the public, the surge of stories about visitors and alignments can feel like portent, and part of our task is to offer a quieter frame. The sky is not speaking in riddles, it is behaving with consistency. What is new is our vantage and our instrumentation, the density of watching that reveals harmonies that earlier eras could not hear. When Earth, a comet, and an interstellar traveller fall along a shared line, the physics that follows is not magic, it is scattering, ionization, and the choreography of charged particles threading magnetic fields. If the coincidence helps us separate those processes, then it has served its purpose and does not need to be anything more. Yet the sense of pattern is not without value. It keeps attention steady through the long weeks when data arrive in thin streams and answers refine by small degrees. It encourages openness, the willingness to admit that models built for local comets may need new terms for foreign ones, that dust can be stranger, that outgassing can be delayed by skins we have not yet parameterized, that rotation states can be tumbling rather than tidy. In this way, the very word coincidence becomes less a dismissal than a prompt. It asks us to test, to compare, to repeat, to let a hypothesis fail with grace, and to replace it with one that fits the light more closely. So we go on, the sun turns, the active regions return to the limb and then faces again. Three-eye Atlas drifts outward, writing a thinner script in dust. Borisov moves through its curve, quiet or not, and then climbs away, between storms. The instruments cool, the analysts breathe, and the models are nudged into better shape. If there is a lesson in this crowded season, it is not that the universe is trying to tell us something, but that it is always telling us the same thing in finer detail. That energy flows, that motion aligns and misaligns, that the laws are steady while our seeing improves. The coincidence is our cue to pay attention. The activity is our laboratory. The rest is patience. In the space of a few days, the planet stepped into the wake of a G3 geomagnetic storm, a surge in the solar wind that set Earth's magnetic field ringing like a struck bell. Instruments at high latitudes traced broad undulations through the magnetosphere. Radio paths bent and rippled. Curtains of aurora spread farther equatorward than usual, and then withdrew with the same quiet suddenness. Forecasters now warn that within the next 12 hours conditions may strengthen again, the next wave already rising out of the sun's rotating face. None of this is unprecedented. The sun has seasons of restlessness, but the timing lays itself against another story already in motion, and the overlap invites questions. Moving through the inner system, close to the path of Venus and nearer to Earth than most new comets manage to wander, C2025, V1 Borisov has held the attention of observers precisely because it refuses to behave as expected. Most comets arriving in this glare carry a visible tail, the long column of dust and ions laid down by sublimating ice under sunlight. Borisov gives us almost none of that. In a run of 10 good observations, only 2 show a faint suggestion of extension. The rest present a compact haze with no decisive sweep. A tailless or nearly tailless comet threading the space between Earth and Three-Eye Atlas, and doing so under an active sun, is enough to send astronomers back over their reductions, recalibrating images and replotting light curves to make sure the oddness is real. The temptation is to reach for connection. Storms rise from the sun, an unusual object passes close. The 2 news lines converge and seem to draw a larger shape. Some suggest that interstellar bodies might modulate the solar wind in their neighbourhoods, or that their dust could seed faint effects that reach beyond their own comet. The physics, however, teaches restraint. Geomagnetic storms are born from the sun's magnetic architecture twisted fields that reconnect and fling plasma into space. Their arrival at Earth depends on the direction of embedded fields and the speed of the wind, not on the presence of small bodies. If there is a link here, it is most likely the link of vantage. We watch more closely when the sun is active. We notice more visitors when our instruments are already awake. Even within that caution there is work to do, and the work is specific. When storms wash through the inner system, iron tails often sharpen under draped magnetic fields, and dust comae can brighten as forward scattering shifts with changing phase angle. If Borisov remains muted while nearby bodies respond, composition steps forward as an explanation. Perhaps grains are larger and settle quickly. Perhaps volatile ices lie buried under a processed crust that resists heat. Perhaps the nucleus rotates in a way that keeps active vents turned away from the sun during the hours when most observations are made. Each hypothesis can be tested against the light. Spectra can search for faint gas emissions. Polarimetry can weigh grain sizes. Repeated photometry can catch any slow heartbeat of rotation that the eye alone cannot see. The calendar adds its own hinge. By calculation, Borisov approaches perihelion on the 16th of November, the day when its distance from the sun reaches a minimum and the balance of heat, spin, and geometry is most likely to tip. Set the three-dimensional solar system model to that date and the picture tightens. The object runs very close to the sun but holds a little above the ecliptic plane, its path a slanted thread that, from Earth's line of sight, nearly resolves into a straight stroke. For a few hours the Earth, the Sun, and Borisov almost share an axis. It is not a meeting, not even a near pass, only the well-known trick of projection, and yet the arrangement is useful. Scattered light becomes easier to interpret when angles are simple. Fainter symmetries in a coma stand out when seen along a clean line. If a stronger storm does arrive in the next half-day, that geometry will offer a laboratory. Instruments that watch the solar wind can time the shock's front. Ground stations can note the first wobble in the geomagnetic field. Telescopes can measure whether Borisov's haze brightens or holds steady, whether 3i Atlas farther out and already proven active answers with its own brief rise. A coincidence then becomes a data set. If nothing changes, that answer is also a result. It tells us that under these conditions this nucleus stays quiet, and it narrows the range of compositions and structures that could explain its behaviour. For the public, the word storm carries drama, and the sight of aurora far from the poles feels like a sign. The karma reading is no less beautiful. We are watching energy move through a system that never rests. Fields threading fields, particles spiralling outward, small bodies drifting through the flow and revealing, by what they do and do not do, the details of their making. Whether Borisov's quiet is coincidence or clue, whether the sun's crowded week is ordinary cycle or rare crest, the method remains the same. Compare, measure, repeat. Let the numbers collect like snow on a ledge. Then step back and read the shape they make. And so the night turns, the magnetometers hum. The auroral ovals breathe. Borisov keeps its counsel, or perhaps prepares to shed it in a sudden pale fan. Farther out, 3i Atlas continues its thin script, a line of dust and ions written by the same star that shakes Earth's skies. If a pattern binds these events, it will declare itself in the data. If not, the coincidence will have served its quieter purpose, to focus attention, to refine instruments, to remind us that our world lives inside weather shaped by a sun that speaks in light, in plasma, and in the long, patient grammar of motion. In the growing stillness of November skies, a strange harmony emerges. 3i Atlas, C 2025 V1 Borisov, and the newcomer A6 Lemon take positions that, when traced on the model of the solar system, seem to blend into a single axis of light. From Earth's viewpoint, their arrangement appears almost deliberate, a line drawn through space, joining planets and comets in a fleeting symmetry. Astronomers call such moments syzygies, alignments born of perspective rather than proximity, yet even knowing that, they cannot help but feel the pull of wonder. Some see the pattern as nothing more than the arithmetic of orbits, an elegant accident in the language of celestial mechanics. Others, more romantic or perhaps more curious, speak of a cosmic signal, a rhythm in the motions of dust and rock that hints at unseen structure. Whether coincidence or message, the effect is mesmerizing. The line of sight from Earth through the sun to these passing bodies forms what looks like a luminous thread woven through the inner system, fragile yet mathematically precise. In this same period the sun grows restless. Great sunspots bloom across its surface. Magnetic fields arch and twist, and loops of plasma erupt into space. Since the 21st of October, a chain of powerful solar storms has been recorded, each surge directed roughly toward the region of 3i Atlas. To some observers, the timing feels more than fortuitous. Alignments above, storms below, a conversation of light and magnetism across millions of kilometers. The three-dimensional solar model makes the geometry plain. Set the date to early November, and the alignment sharpens the Earth. the Sun, and a 6 lemon falling into almost perfect linearity rotate the view, and the pattern extends outward toward Atlas and Borisov, as though the entire inner solar system had, for a brief moment, settled into resonance. Scientists resist metaphor, but they acknowledge the resonance effect. Alignments can modulate how solar energy interacts with planetary magnetic fields, not by intention but by structure. The geometry of the system, like the shape of an instrument, influences the tone of its vibrations. For this reason, many predict that solar activity will remain high for days, perhaps weeks. The star's dynamo is in an excited phase. Its fields are tangled and primed for release. Each eruption sends charged particles streaming outward, and when those fronts meet the magnetic shields of planets or the ion tails of comets, they spark brief, measurable effects. The current alignment ensures that several of these bodies, Earth among them, sit along the same corridors of solar wind. To researchers, this is not a mystery but a laboratory, an alignment that allows simultaneous observation across multiple points of space. Still, the poetry of coincidence endures. Borisov, small and reticent, travels between Earth and Atlas like a messenger with sealed pages. Atlas, scarred by earlier storms, glows faintly as it climbs toward Jupiter. Lemon, nearer the Sun, seems poised to feel the next wave of radiation head-on. Each plays a role in a larger choreography that is both predictable and surprising. The mechanics well understood, the timing never quite the same twice. From observatories across the world, data streams in spectra of solar flares, magnetometer traces, faint images of dust and gas. The numbers confirm what the eye already senses. The system is alive with motion, its parts linked by gravity, magnetism, and the accidents of alignment. Whether we call it coincidence or signal, the sight reminds us of scale. We live within a web of relationships too vast to perceive in full, yet simple enough to model on a screen. In the days to come, as the Sun continues to flare and the three travellers move on from their temporary harmony, the question will linger. Was this only geometry, or something deeper, an echo of the universe's own cadence? For now, the answer remains written in the stars, waiting for us to measure it again when the next line of light is drawn across the dark. In recent months, a quiet astonishment has settled over those who keep the night's ledger. One after another, unusual visitors have appeared within the inner solar system, faint lights moving on steep, uneasy paths that do not fit the familiar cadence of our long-period comets. C-2025, V1 Borisov has become the emblem of this feeling, not because it is spectacular, but because it is timely. By most measures, it is likely an ordinary comet, a small nucleus, a tight haze, a hesitant or absent tail, yet its discovery arrived at precisely the moment when Three-Eye Atlas was bright in our collective attention, and Earth's own skies were alive with solar weather. To find Borisov apparently threaded between Atlas and our world is to feel the twinge of pattern, the sense that separate events are rhyming along a line we do not yet fully hear. Is this only coincidence, the arithmetic of orbits and the sharpening of our surveys, or is it a link in a longer chain? An echo of rules we have not yet written down. The discipline teaches caution. Modern sky searches are relentless. They sweep wider fields with deeper exposures than any previous generation, and so they catch more of the faint, the brief, the oblique. But caution is not indifference. Some analysts argue that our language lags behind our seeing, that to name every fast outsider a comet is to load it with expectations forged by local examples. An object born under another sun may carry a different balance of ices, a crust seasoned by other cosmic rays, a porosity stitched by other temperatures. It may hoard its volatiles beneath a hardened skin so that sunlight coaxes only a dim veil where we anticipate a streaming plume. When such bodies refuse a tail, or change colour under angles that would not move a homegrown nucleus, the discrepancy is not a problem to be waved away. It is a measurement, pointing to a chemistry or a structure our models have not yet earned. There is no need to lean on romance. None of this implies intent, or technology, or visitors cloaked in artifice. The sky is full of meanings that do not require minds to make them. If there is a signal here, it is not a message but a coherence, a season in which solar activity rises, in which alignments grow neat by chance and geometry, in which our instruments are awake and our attention is tuned. In such seasons, the system feels more legible because the flows are louder. Charged particles trace the sun's spiraled fields with a firmer hand, comets and tails. When present, answer more plainly. Small differences in dust size and gas composition stand out in reflected light as though underlined. Some reaching for a metaphor equal to the mood. Call it a simulation turned real, a rehearsal of overlapping phenomena that once lived only in scenario planning. An interstellar-flavoured object crosses an active longitude. Another visitor brightens beyond perihelion. Earth's own magnetosphere shudders under a storm, and all three are observed with instruments capable of timing, spectra, and polarization in the same breath. The point of the comparison is not drama but pedagogy. We are being taught, by circumstance, to integrate. The lesson is to hold more than one mechanism in view at once and to watch how they interfere, as waves do, until a stable picture emerges. Meanwhile, the sun continues its work. Since the third week of October, eruptions have risen from sprawling active regions and folded outward through the inner system. In the span of only a few days, our planet stood inside a G3 geomagnetic storm, the field ringing and settling like a struck bell, auroral curtains widening and then drawing back. New warnings follow in a measured cadence. There may be another surge within the next half-day, a shock front already in transit, an embedded field turned southward enough to couple powerfully with Earth's magnetosphere. Against that weather, the catalogue of visitors is reread, not for omen, but for opportunity. Does a tailless or near-tailless body like Borisov brighten at the edges when a storm passes, or does it remain a stubborn ember? Do spectra find even a thread of gas when the solar wind sharpens the draped magnetic field? Does polarimetry hint at larger grains, the kind that keep close and mute the classic fan of dust? What surprises many is less any single answer than the recurrence itself, the way similar questions return with each newcomer, as though the system were offering variations on a theme. Recurrence is not redundancy, it is resolution. Each pass through the same inquiry narrows a parameter, fixes an uncertainty, replaces a hand-drawn arrow with a measured vector. It is how a vague idea, perhaps interstellar bodies carry different skins, becomes a model parameter with a range and a confidence bar. It is also how humility is kept, because recurrence tells us when a beautiful hypothesis refuses to fit the light, so we proceed in the manner the sky rewards, patient, precise, more open than credulous and more curious than dismissive. We allow that the word comet may be a beginning, not a conclusion. We accept that coincidence can be both commonplace and instructive. We read the solar storms as weather and as instrument, noise and signal at once, their turbulence turning faint differences into visible contrasts. And we hold Borisov where it belongs in context, not as an omen but as a timely probe of what small, cold bodies can be when they are made elsewhere. If there is a deeper rule tying these appearances together, it will show itself in repetition. If not, the repetition will still have done its better work. It will have trained us to look, to measure, and to change our minds when the sky insists. Warnings spread quickly through the global space weather network. Within the next 12 hours, another geomagnetic storm may strike, stronger than the G3 event that already shook Earth's magnetic field. Instruments watching the solar wind show density rising, magnetic polarity turning southward, the sure prelude to turbulence in our upper atmosphere. Against this background, the small visitor, C2025 V1 Borisov, continues its quiet motion through the inner solar system, near the orbit of Venus and, by projection, closer to Earth than any other recent interstellar object. The coincidence of timing and position has renewed an uneasy question. Could there be a connection between such travellers and the sun's unpredictable temper, or are we simply seeing patterns where none exist? What puzzles astronomers most is Borisov's silence. In the 10 observation reports logged since its discovery, only 2 describe even a faint trace of a tail, an arc of light between 50 and 72 arc-seconds long, delicate as smoke. The other 8 show a compact haze, circular and self-contained, as though the nucleus was sealed behind a crust that refuses to yield gas or dust. A tailless comet, crossing the space between Earth and 3i Atlas while the sun flares violently, is a tableau that seems to defy the usual logic of comets. Heat should wake them, radiation should carve jets and fans, yet here is a body that glows without gesture, a lamp with its wick unlit. The minor planet's electronic circular, managed by the International Astronomical Union, has become the clearinghouse for this story. Each night's report adds another thread: coordinates, brightness, changes in apparent magnitude, spectral notes, and brief remarks from observatories across the world. The first came from Borisov himself, the Crimean observer whose name the object bears, using an advanced reflecting telescope. He recorded the new point of light against the star field and noted, simply, "No visible tail." Subsequent submissions from facilities in Chile, Hawaii, the Canary Islands, and Japan confirmed the same. A few under better seen conditions described a faint, uneven elongation, uncertain enough to be classified as possible instrumental scatter. In other words, the evidence remains equivocal. The comet might have a tail so thin that only the next generation of sensors could verify it, or it might truly be inert, a frozen nucleus holding its breath under the sun. The lack of activity raises practical questions as well as philosophical ones. If the object is indeed interstellar, its crust could be heavily processed by cosmic rays, forming a refractory shell that seals in volatiles. In that case, even the intense heat near perihelion might be insufficient to pierce the armor. Alternatively, the nucleus could be rotating in such a way that the same inert face always points sunward, keeping active vents hidden in shadow. Another possibility, less dramatic but equally intriguing, is that Borisov carries fewer light volatiles than typical comets, making sublimation slower and dimmer. Each hypothesis can be tested, and each has begun to be, in the meantime. The sunstorms continue to arrive. Magnetometers register waves that crest and fall across polar regions. Satellites ride fluctuations in charged particles. Auroral ovals widen again, painting new colours in the night. Some commentators draw the two stories together, imagining that the presence of interstellar material within the heliosphere might subtly alter how solar energy propagates. The physics offers no clear bridge. These bodies are too small, too distant to affect the star, but the coincidence serves its own purpose. It focuses attention in the thick of data and noise. Patterns are easier to test when minds are alert to them. For working astronomers, the next milestone is the 16th of November, when Borisov reaches perihelion. The plan is to gather high-resolution images across the electromagnetic spectrum: optical, infrared, ultraviolet, to determine whether the nucleus shows any late awakening. If no change appears, the data will refine our models of what a long-travelled, radiation-hardened body can endure. If a tail does bloom, even faintly, the moment will record the threshold temperature and time that broke its silence. Either way, the answer will lengthen the timeline of understanding that began when the first interstellar visitors startled us years ago. For now, the reports continue to trickle in. Terse, factual, strangely lyrical in their accumulation. Magnitude 11.9, no tail visible. Magnitude 11.8, slight asymmetry eastward. Each line a fragment of patience, each echoing across the shared network of watchers. Through them we glimpse not just the object itself, but the discipline it inspires: a commitment to measure without haste, to accept ambiguity, to let the universe reveal itself one quiet data point at a time. The latest reports return with a strange mixture of clarity and doubt. Observers agree that C2025 V1 Borisov shows little to no tail. What disagreement remains lies in the faintest of hints, a wisp seen in two accounts and absent in the rest. From this uneven record, a cautious sentence takes shape. Borisov appears nearly tailless. The comparison that follows is inevitable. 3i Atlas, farther from the sun yet many times brighter, throws out narrow jets and a persistent coma. The two travellers could not be more different in posture, yet on the sky they now share nearly the same thread through Virgo, a near collinearity that turns coincidence into conversation. When things line up, minds do as well. Hypotheses gather like small birds along a wire. One such idea arrives with the magnetism of a story. Suppose, some say, that a smaller fragment had been launched from 3i Atlas along our line of sight, thrown loose by outgassing, nudged by rotation, then steered by sunlight. Would it not look like Borisov looks now? Dim, small, reluctant to grow a tail. The pieces seem to fit at a glance. A fainter body would carry less volatile material and could remain shrouded in dust rather than plume. It would ride near the larger traveller on the sky and, for a few mornings, appear to share its path. But the closer one weighs the thought, the more careful it must become. The space between these objects is vast. The speeds involved are immense. The odds that a fragment ejected from an interstellar nucleus would adopt a trajectory that places it neatly between Earth and its parent, while retaining a separate identity, are slim. Dynamics favours independence. Still, speculation has its use when handled with gloves. It marks what would have to be true for the idea to survive: a specific ejection geometry, a measured non-gravitational acceleration consistent with gentle thrust from sublimation, a light curve that tracks with distance rather than with the mood of the solar wind. Those requirements can be tested. If the numbers refuse them, the hypothesis retires with honour. If they hold, the story earns a second reading. In the meantime, other explanations keep their quiet claims. A tailless appearance may signal a crust processed by long ages of cosmic rays, a dark rind that seals in volatiles until higher heat or a new fracture opens a vent. It may imply larger dust grains that scatter sunlight without travelling far, muting any graceful sweep. It may be the work of geometry alone, with the main ion tail nearly aligned with our line of sight, so that what exists cannot be separated from the coma that hides it. Even rotation can play a part, a tumble that keeps active regions turned away during the hours when we are watching. None of these require kinship between Borisov and Atlas. All of them respect the broader lesson that bodies formed under other suns may keep different balances of ice and dust, different habits of heat. To disentangle romance from physics, astronomers turn to their instruments and, just as importantly, to their models of the sky itself, the familiar stellarium software. Driven by precise ephemerides from the planetary catalogues maintained by NASA, now serves as a shared window on the unfolding scene. At 6 in the morning on the 7th of November, with the simulation set for a clear horizon, constellation lines traced, and atmospheric refraction disabled, the view places 3I Atlas, C2025 V1 Borisov, and C2025 K1 Atlas in the morning sky, low and pale along the edge of dawn. In that digital stillness, distances compress. The three lights gather into a tidy embroidery across Virgo. The great circles of their orbits cross with ruler-straight authority. The map is not the territory, and the territory is not a stage, and yet the arrangement has the grace of choreography. It tells observers when to look, where to place a slit for spectroscopy, how to time exposures to avoid the brightening rim of day. It also gives the public something the raw numbers cannot, a sense of how these motions relate to one another, of how a straight line on the sky is made from curves in space. By mid-simulation, the practical work resumes. Teams plan deeper stacks to push the signal of any tail out of the noise. Spectra are cued to hunt for faint emission from cyanogen, from carbon monoxide, from water broken by sunlight into its glowing parts. Polarimetry is set to weigh grain sizes by the way scattered light twists. If Borisov remains mute, that silence will narrow the list of possible interiors. If it wakes, even briefly, the timing will mark the threshold of heat that broke its seal. Either way, Virgo remains the stage on which the questions are asked, and the alignment that first drew our eye Earth, Borisov. Atlas along nearly the same stripe becomes a laboratory rather than a portent. Is it chance, or the outline of something deeper? The honest answer is that the sky often looks meaningful when our attention is high and our models are still learning. But meaning does grow from repetition. Should alignments like this one return with new visitors? Should tailless comet recur under similar angles and distances? Should brightness patterns echo across different bodies born under different suns? Then what we call coincidence today may ripen into rule. Until then, the most faithful posture is the one taken by the instruments just before dawn. Steady, patient, open to surprise, and calibrated to let the universe speak in its own even voice. On today's star map, the interstellar visitor 3I Atlas holds its place in Virgo, having slipped across the path of Venus only a few days before. Nearby, almost laid upon the same stitch of sky, the newcomer C2025 V1 Borisov lingers so close in apparent position that, to an observer on Earth, the two seem like companions, separate stories sharing a single line of sight. Swing your view a little northwest along the zodiac and you meet C2025 K1 Atlas in Leo, its honeyed plume arcing outward. Together these 3 points sketch a quiet geometry Virgo to Leo, east to west an airy triangle in which much of the month curiosity is gathered. It is not that the sky is empty elsewhere, it is that this region, for the moment, feels resonant, as though a few notes are being struck again and again in close harmony. The latest portrait of Borisov heightens that feeling. Dated the 3rd of November. It carries the object's original catalogue label GB00000810 A plane, provisional name that precedes the title now carried in public bulletins. The image is not a single snap, but a careful stack of frames, each exposure tracked on the motion of the object rather than the stars. The result is a small miracle of intention, the comet sharp. The background sky transformed into long pale strokes where the constellations have slid across the sensor. Those streaks are not errors but signatures. They tell you the telescope followed Borisov faithfully, kept it pinned while the heavens moved, and so whatever structure is present around the nucleus should stand out. It does not. Even under that scrutiny, the object remains a compact haze, round and reticent, with no certain tail. This restraint would be unremarkable in the outer reaches, where sunlight is weak and ice is slow to lift. It becomes striking here, where angles are favourable and the sun's voice is loud. Just to one side, 3i Atlas shows the opposite temperament, its narrow jets teased by the solar wind, and its brightness still elevated beyond simple predictions. Put the two together on the same patch of sky, and you invite a question that will not go away. Are they merely passing through the same field from our point of view, or does their shared projection hint at a deeper pattern in how visitors from beyond our system thread the inner region? The safe answer begins with geometry. Lines that appear to meet on a dome do not meet in space. The triangle Virgo-Leo-Virgo is a figure drawn by perspective, not proximity, yet even within that caution there is room for inquiry, because projection can both hide and reveal. When a tail runs nearly along our line of sight, it vanishes into the coma. When two bodies fall upon the same great circle, subtle differences in colour and polarization become easier to compare, because the background and the phase angles are nearly matched. For this reason, observers have turned the region into a laboratory. By keeping the atmosphere off in their simulators, by marking the constellation lines and turning the clock to the hour before sunrise, they outline a clean field in which to measure stellarium, driven by the precise ephemerides maintained in the major catalogues. Provides the timing. The telescopes supply the light. Virgo holds 3i Atlas and Borisov low in the morning, just where the horizon begins to brighten. Leo keeps K1 Atlas a little higher, its golden fan easier to separate from the dawn. Exposure plans follow from that simple layout. Short stacks first, to freeze shape and test focus. Longer stacks once the tracking is proven steady. A sequence at small intervals to catch any pulse that might betray rotation. Spectra are cued at the same moments each morning so that changing air does not masquerade as changing chemistry. The coincidence that first drew notice the near collinearity of Atlas and Borisov has become the frame in which these comparisons are made. If Borisov remains mute, that silence will be read not as refusal but as description, a crust too seasoned by radiation to vent easily, grains too large to fly, a tail pointed almost directly away from us and therefore hidden. If a faint extension appears in only certain filters, the colour will tell us what kind of particles are doing the scattering. If the ion component of 3i Atlas sharpens during a solar gust while Borisov keeps its compact glow, composition moves to the centre of the explanation. Every outcome narrows the field of what these bodies can be, and so the sky over Virgo and Leo becomes both chart and question. The rare closeness in appearance of 3i Atlas and Borisov, coupled with the steadfast presence of K1 Atlas to the west, is less a portent than an invitation. It asks us to watch with patience, to let the instruments do their counting, and to remember that a straight line on the map is a thread spun from curves in space. Whether these travellers are merely sharing our gaze or participating in some deeper rhyme of motion, the way to know is the same as it has always been. Return to the field before dawn, set the clock, steady the mount, and gather the light until the question begins to answer itself. In the same region of sky where Virgo and Leo seem to braid their own quiet narrative, a new thread has been announced, and it concerns the interstellar visitor that has occupied so much of our attention. The latest image of 3i Atlas comes not from Earth but from Mars specifically, from China's Tianwen orbiter, which trained a modest camera outward during the first days of October and captured a dim trace against the glow. Rumour had carried these frames ahead of any formal release. but now the China National Space Center has confirmed them and placed a representative still in the public record. The photograph is spare, a faint speck adrift behind a darker limb. The suggestion of motion written as a soft shift between successive exposures. In official captions, the bright point is identified as the interstellar object itself. Some commentators even call the leading pixel a tip, though that word implies a shape the data do not yet earn. The disappointment, voiced almost immediately by professionals and amateurs alike, is not about intent but about limits. The resolution is low, the compression high, and the instrument never meant to do this work. What we have is an image that proves the act of seeing but does not provide a surface to study. You can measure the direction of motion and place a rough bound on brightness. You cannot, with confidence, count jets, resolve a comma's texture, or weigh particle sizes by light alone. It is a postcard from a distant friend, proof of presence. Little more. Still, even postcards matter. Seen from orbit around another world, Atlas confirms both its path and our reach. And sometimes that is enough to justify a line in the logbook. Elsewhere the mood is anticipatory. The international community looks toward the Mars Reconnaissance Orbiter and the eye it carries. The high-rise camera whose crisp stare has mapped dunes and dust devils with painterly detail for years. If any off-Earth instrument could separate a faint coma from the glare and lay a narrow tail against the darkness, it would be this one. Requests have gone forward. Schedules have been proposed. In one report, a member of Congress is said to have written directly, urging that any frames containing Atlas be processed and released without delay. The response, careful and procedural, points to the realities that govern data rather than the wishes that follow discovery. Images will flow when operations are stable again, when backlogs are cleared, when the administrative weather brightens. For a public tuned to the tempo of breaking news, such answers feel evasive. For those who live by spacecraft, they sound like the ordinary cadence of work. Between these two poles, an image too soft to satisfy, and a promise not yet kept, there is still room for science. The Tanwin frames, however coarse, anchor a viewpoint. From Mars, the Sun Object Observer angle differs from Earth's by just enough to test how forward scattering might steepen a coma's brightness, or how an ion component might align under local solar wind. Combine these values with ground-based measurements and the geometry becomes a tool, not a tease. With careful cross-calibration, two imperfect views can produce one useful constraint. The method is older than any agency. Triangulation, patience, and the modesty to take what the sky is willing to give. There is also the matter of expectation. We have, perhaps without noticing, become accustomed to photographs that answer rather than ask. The first visitors from beyond our system taught a different lesson. Most of what we learn arrives as small adjustments to prior maps, increments of certainty that replace attractive guesses. In that spirit, the Chinese release is not a revelation but a datum. One more point on a curve that began when Atlas brightened in the weeks after perihelion. It tells us the object was where Ephemerides placed it. It hints that the coma was neither explosively large nor entirely absent. It suggests that the viewing geometry from Mars was no miracle cure for the confusion we experience from Earth. All of which is valuable because the next images, whether from high-rise or from a deep stack on a mountain before dawn, will be read against this baseline. Meanwhile, the conversation continues across familiar channels. Observatories compare timestamps, correcting for light time and for the slow wheel of planets. Modelers update scattering functions to see whether a dust-dominated coma could masquerade as a point under certain angles. Spectroscopists argue for slits placed just off-center to catch any whisper of ion glow beyond the glare. None of this depends on drama. It depends on the same discipline that turned a rumour into a release and a release into a place on the chart. And so, in the shared field of Virgo and Leo, we add an image that clarifies less than it confirms, and we wait for another that may do the reverse. Between them stretches the ordinary bridge of inquiry, imperfect data on one side, patient analysis on the other, a promise of sharper seeing when the instruments are ready. If the public grows restless, that restlessness is itself a kind of tribute evidence that a faint point of light beyond Mars can still persuade us to look up, to ask for better pictures, and to accept that sometimes the sky answers in steps rather than leaps. Across the world's observatories, anticipation builds for the next image of 3i Atlas. Analysts believe that if the long-awaited high-rise photographs from NASA's Mars Reconnaissance Orbiter are finally released, they will reveal what earlier cameras could not: the object's true size, its shape, perhaps even hints of composition drawn from how sunlight scatters across its surface. Others, more guarded, suggest that expectations may exceed reality. The picture, they warn, may look little better than the low-resolution frame released from China, another blur suspended in shadow, as if filmed with a potato machine. One researcher joked with weary affection, humour aside, the scientific stakes are serious. A clear image would transform guesses into geometry, how large the nucleus really is, whether the brightness arises from reflective crust or from gas and dust, whether jets emerge in any direction. Without it, 3i Atlas remains an outline coordinates, magnitudes, and speculation. The Chinese Tanwen probe's frames confirmed existence but not identity. Now, as data trickle in from the planetary archives, all eyes turn toward instruments with longer reach and finer optics. The Hubble Space Telescope, still orbiting faithfully in Earth's shadow, and the James Webb Space Telescope, poised far beyond the Moon's influence at the quiet balance point of L2. Each is capable of capturing both image and spectrum, of turning light into chemistry. Together they hold the best hope of pulling this visitor into focus, yet the path to such clarity is not purely technical. Researchers face barriers as layered as the sky itself: data allocation schedules, proprietary embargoes, the pauses imposed by politics. The recent government shutdown in the United States has frozen several review queues. Missions that rely on those channels wait, instruments ready, but paperwork still. Astronomers express their frustration in cautious tones. The universe keeps moving while our bureaucracies sleep. In China, by contrast, the CNSA has released its Tanwen data weeks after internal review, inviting collaboration across borders. The gesture underscores a growing truth that no single nation can now claim the sky's discoveries as its own. Meanwhile, telescopes on Earth resume their long watch. From mountaintops in Chile, Hawaii, and the Canary Islands, observers track the faint motion of 3i Atlas as it climbs away from perihelion. Even through atmospheric blur, ground-based instruments can refine its orbit, test its spin, and note any fluctuation in brightness that might betray rotation or venting. Each observation adds a line to the mosaic, and every piece matters. With interstellar bodies, repetition builds reality. The more nights recorded, the tighter the uncertainties shrink. Behind the precision lies a larger question: why this matters beyond curiosity. To study objects like Atlas is to widen the map of possible materials and histories. Each interstellar visitor carries a sample of chemistry forged around another star, shaped by another protoplanetary disk, aged by cosmic radiation in regions our probes may never reach. Measuring how such matter behaves under solar wind gives clues to how our own system interacts with the broader galactic environment. For planetary scientists and futurists alike, those clues extend to strategy, how spacecraft might shield themselves in alien space, how colonists could harvest resources from icy bodies far from home. Some thinkers tie these investigations to visions of the future: a permanent research base on Ganymede, Jupiter's vast moon believed to conceal oceans beneath kilometers of ice. Understanding how radiation sculpts interstellar ice today could inform how we mine or protect such materials tomorrow. In this way, every photon reflected from 3i Atlas is a rehearsal for exploration, a note in humanity's longer score of survival beyond Earth. For now, the cosmic conversation continues in fragments: a low-resolution image from Mars, the promise of one from NASA, fresh spectra from Hubble and Webb still waiting in digital queues. Between them stretches the patient rhythm of science argument, calibration, release. The sky will not hurry for us, and perhaps that is the lesson these blurs impart. Each pixel, no matter how grainy, is a reminder that knowledge often arrives not in revelation but in accumulation. What we call disappointment today may, months from now, become the cornerstone of understanding the moment when we learned how to see an interstellar traveller not as mystery or omen, but as a mirror held up to our own determination to know.